Hey folks, welcome back. The final example in Chapter 5. This one's kind of just for fun. I would like to look at a collisions question, but we're going to make it a Hollywood collisions question. This goes with a lot of classic sort of like shoot 'em up action movies like Die Hard, which is kind of weird. It is voted the #1 holiday movie by Americans. Our neighbors to the south. A different group in terms of holiday movies. I wouldn't really call some shoot 'em up action movie like Die Hard a holiday movie, but they voted it #1. That's okay. We have the evil villain, Bruce Willis, the hero. And in a lot of these old school sort of action shoot 'em up movies that I grew up with, what will happen is at some point in the movie, the hero and the villain will end up sort of shooting at each other, and then somehow they'll both lose their guns, and then they end up in this like hand-to-hand combat where they're beating the snot out of each other, and typically the villain at some point gets the upper hand. So they kind of beat the hero down, they have a gun pointed at them, and instead of just sort of finishing off the hero, they stand and give this speech about how their evil plan will go off just without a hitch once the hero is gone, once the hero has been dispatched of. And while the henchman, the evil villain, is giving that spiel, typically the hero will like look over and find one of the guns on the floor and sort of grab it without the villain noticing, or do some barrel roll, and he'll grab it, he'll fire the gun at the villain. And when the villain is struck by the bullet, this is a Hollywood example, right? So only in Hollywood, we're not trying this. The bullet sticks to, I'm saying that in air quotes, sticks to the villain, and the villain goes flying backwards, right? Just flying backwards. And if it's a movie like Die Hard, they might be up in the top floor of like some big tower. If you've seen the movie, you kind of know what I'm talking about. And the villain might be standing in front of a large glass window. And when they get hit by the bullet, they go flying backwards and they fall or break through this big glass window and they fall to their death many stories down below. What I want to look at is if you were to be struck by something like, let's say a paintball. That's a little bit more school appropriate, right? A paintball. Even if it was going really fast, would it give you enough backwards velocity to have you like break through a big glass window? Because it looks fantastic and people like it, Americans like it, when they're watching their action flicks. But what does the physics say? So let's try this, the before scenario. Again, making this school appropriate. Got this guy with a wicked Nerf gun and even a crazy looking mask on. He is going to fire a 20-gram Nerf bullet, which is traveling at real gun speeds, 300 meters per second, because physics, out of this modified Nerf gun. It's going to strike a villain who's 70 kilograms and stationary, right? Giving their big speech about how their evil plan's going to go off so well together. And for the after, let's assume they stick together. So the Nerf bullet has one of those little suction tips and it sticks to the villain. So this is our school-appropriate version of that Hollywood shoot-'em-up example. So you head to your formula sheet. You find that the sum of the initial momentums is equal to the sum of the final momentums. Now do watch that Mr. Arcuri was helping us in this question. 20 grams, you have to divide by 1,000 to turn that Nerf bullet into kilograms. So that is going to be 0.020. There's the mass of the bullet, traveling at 300 meters per second, momentum #1. Plus, we've got this villain who's stationary, 70 kilograms and not moving. And I see all the time that students make weird algebra mistakes, like 70 times 0 comes out at 70. Well, there actually is no momentum there, so I'm just going to cross it out right away. And here they stick together, so the villain plus the mass of the bullet, the Nerf bullet, 70.02, And we want to know what the final velocity is. How quickly does this villain and the bullet go flying backwards? Is it enough to break through a glass window? So if you run these numbers, check this out. 0.02 times 300, 6 plus 0. So that's all we've got on that left-hand side. So 6 equals 70.02 times VF. And if we take that value and we divide by 70.02, 0.086. 0.086 meters per second. That's very, very slow. In fact, if we convert that into units that maybe are easier to picture, multiply by 100 to turn it into centimeters. This is just so we can picture what's going on. That gives the villain a final velocity of 8.6 centimeters per second. So is that enough to make them go flying backwards through a glass window? Psh, looks great on camera. No. Like, I doubt you'd even step backwards, to be honest. Maybe you take one step back and go, ugh. But that's it. You're certainly not going to go flying backwards. So unfortunately, with this example, we have debunked some classic sort of Hollywood action movies. Sorry about that. We're kind of doing a Mythbuster style thing here, I guess. I guess the one thing to keep in mind is if you did fire a big enough bullet with enough velocity that it actually could hit an object and cause it to go flying backwards, what would that mean for the person on the other side of the gun? So if you actually did fire a Nerf bullet that was really big and heavy at this villain and made them go flying backwards with enough force to break through a window, then this poor fellow shooting the gun, because of action-reaction forces, would also feel this massive recoil, right? And if they were in front of a glass window on the other side of the room, they'd also go flying backwards through the window and fall to their death. So it's one of those tricky situations where if you want to make somebody go flying backwards with this Nerf gun, then you're going flying backwards with the Nerf gun too. It's going to have some serious kickback. Anyways, random curse of the physicist moment. You've made it to the end of chapter 5. There is, I think, if you look at this box of homework, it's the second collision day. There's a couple more questions for you to try. Just check out your chapter outline. And then we're at the end of the chapter, so you can move into the review. And you'll find there are 2 documents in there in the All Resources folder. One, I think it's just called the Chapter 5 Review. Actually, let me double check. I'll pull it up. So a couple of great review documents for you. One of them is called the Chapter 5 Review. Again, hopefully you can see this. On one side, it's called Extra Practice. It's all just review from this chapter. The other side is officially called the Chapter 5 Review. You will find that there is an answer key to this in the All Resources folder as well. So Chapter 5 Review, and then you've got the Chapter 5 Review and Extra Practice key. There's also something I put in there called the Chapter 5 Need to Know. That's the teacher version is the answer key. If you open up the Chapter 5 Need to Know, this breaks the chapter down where I've actually specifically said, hey, here are the different ideas we've looked at in this chapter. And then here are some questions based on those ideas. So this is a really good one because you can see it says, hey, we talked about the force of gravity, and then some specific types of questions. Hey, we talked about forces of friction, spring and elastic forces. Here's a couple different kinds of questions. So try those documents out for practice. There will be a test coming at you at some point. Might look a little bit different than the last test. I think I'll have some set questions and then also some create your own questions, kind of like the choose your own adventure that you guys did last time. So look for that coming. I'll send an email out and have instructions for that test online at some point. But for this week, let's finish off the week by just playing around with some review. Try those questions out. Hit me up on Zoom or via email if you've got questions about anything on that review. And I hope you can join me for the Zoom sessions too, because I have another document if a bunch of us get together. I have another document that's kind of fun. It's like a little online quiz we can do together. Some different style questions that make you think a little bit. And it would be, I believe very useful for you to test your knowledge, especially of FNet equals MA. So join me this week for the Zoom meetings. We'll try that out. We can go over any of these questions if you want me to. Hopefully you do. And then towards the end of the week, we'll start looking towards that Chapter 5 test. So join me for Zoom. Hit me up with any questions. We'll chat soon.